All right, now we're here with chapter 2, and we're going to start by solving some equations. These are with rational coefficients. Rational, ladies and gentlemen, literally just means fraction. It can be a fraction, so don't get too scared. It's not that bad. I'm right with you. My name is Mr. Hain, and here is our essential question for today's lesson, or this video's lesson. What does the inverse operation mean, and how do I use inverses to solve equations? All right, let's dive right in. All right, so first, our example A, we have to solve the equation 3 over 4c equals 18, or 3/4 c equals 18. All right, so the first thing I got to do is I got to realize that I am multiplying. So 3/4 is multiplying the variable c. When I'm multiplying, one-step equations need me to perform inverse operations, or any equation needs you to perform inverse operations to isolate that variable. So I'm going to multiply by the reciprocal. Now, you just heard me say inverse of multiplication, and you might be saying that is division. But when you divide with fractions, you take the reciprocal of the fraction and multiply. A lot of other teachers in other grades say keep, change, flip, but I just prefer multiplying by the reciprocal is the same as dividing with fractions. So I go ahead and I multiply by the reciprocal, so both sides multiply by 4 over 3. It's the reciprocal of the coefficient of the variable. So on the left-hand side, 4/3 times 3/4 cancels to 1. And on the right-hand side of the equation, I have 18 over 1, making that a fraction, multiplied by 4 over 3. Now, some people are going to multiply straight on through, and they're going to get a number and then divide that number by 3. I like to cross cancel. So when I cross cancel, I'm specifically looking at the diagonals. So 18 is the numerator and 3 is the denominator that I'm multiplying. And 3 and 18 share a factor, and that factor is 3. So that's how I can divide. I divide 3 divided by 3 gives me 1, and 18 divided by 3 gives me 6. So I can't cancel 1 and 4. There are no common factors other than 1. So I'm going to multiply straight across. 6 times 4 is 24. 1 times 1 is 1, so 24 divided by 1 is 24, and c is equal to 24. All right, so I got 4 more examples. B is 1/5 times x is equal to 12. C is negative 2 over 9 times d is equal to 4. D is 15 equals 5/3 times n. And E is negative 24 is equal to negative 6 over 7 times P. Excellent. So these are your 4 example questions. What I'd like you to do is go ahead and pause the video and work those out the same way that I did with example A. Pausing the video lets you see all of my work and know the steps that you need to solve examples B, C, D, and E. Go ahead and pause the video. I'll be here when you get back. So now we're talking with example F with mixed numbers. How do you solve mixed number fractions? So I'm going to take the two fractions and I'm going to make them improper. So the problem is 1.5 s, or 1.5 times s, is equal to 16.5. So I'm going to take the 1.5 and the 16.5 and make them improper fractions. So 1 and 1/2. The 2 is the denominator for the fraction, which is 1/2. I'm going to multiply 2 times 1. Multiply, and then I'm going to add the answer 2 to 1. That gives me 3 over 2. The exact same thing is what I'm going to do with 16 and 1/2. 2 times 16 is 32, and 32 plus 1 is equal to 33 over 2. Now, the next step is to rewrite my original problem with my improper fractions. So I have 3 over 2 times s is equal to 33 divided by 2. So this is the exact same type of problem that we saw in our last A through E examples. So now I can just isolate the variable by multiplying times the reciprocal of the coefficient of s, which is 3/2. And the reciprocal of 3/2 is 2 over 3. So I multiply each side. I'm going to cross cancel. And I see, since I multiply 33 over 2 times 2 over 3, The 33 and the 3, the numerator of the first fraction, the denominator of the second fraction, can be canceled. And the 2's can cancel. So the 3 goes into 3 once and 33 11 times. And 2 divides by 2 for both. So now I have 11 times 1 and 1 times 11. That's equal to 11. So I know that S is equal to 11. Awesome. So now we have 3 examples for you to work on. Examples G, which is 4 and 1/6 is equal to 3 and 1/3 times C. Example H, which is -9 and 5/8 times W, is equal to 108. And example I, which is 1 and 7/8 times Y, is equal to 4 1/2. Let's do these 3 examples. Pause the video and I'll be here when you get back. This brings us to J. So example J is dealing with decimals. What about those decimals? So I have 3 and 15 hundredths, or 3.15, is equal to 45 hundredths times n, or 0.45 times n. So the first thing I see is that 0.45, or 45 hundredths, is multiplying n. And the inverse of multiplication is division. So I'm going to divide both sides by the coefficient of the variable, which is 0.45. And that cancels on the right-hand side of the equation. 0.45 divided by 0.45, of course, is 1. I use my calculator, and I know that 3 and 15 hundredths divided by 45 hundredths is 7. That leaves us with 3 examples for you to do, K, L, and M. K is 4 and 9/10, or 4.9, is equal to 7/10, or 0.7 times T. So 4.9 equals 0.7 times T. Example L is -1.4 times M, which is equal to 2.1, or -1.1 and 4/10 times M is equal to 2 and 1/10. Example M is 5 and 6/10 times K is equal to -12 and 88 hundredths, or 5.6 times K equals -12.88. All right, go ahead and pause the video, work out K, L, and M using J as a guide, and I'll be here when you get back. So we got a quick application problem to kind of hold all of this home. So example N is everyone's favorite, which is a word problem. So Latoya's softball team won 75%, or 18 of its games. So we got to define a variable, then write and solve an equation to determine the number of games the team played, or total games. So let's think about this. 75% of 18 games, or 75% was 18. So I don't know the total, but I know that 75% of some number, or 75% of X games, is 18. And I know that the word of is multiplication. We don't know how many games, so I'm going to use the variable X. Is equals, and 18 is the part, or 75%. So 0.75 times X is equal to 18. Awesome. This is just like my last example. I'm going to divide by the coefficient of X, and that gets me 24 total games. Sweet. So example O, which is on your own, is for Deshaun's baseball team, who won 70%, or 14 of its games. How many games did his team play in total that season? Go ahead and pause the video, complete example O, just like example N, and I'll be here when you get back. And guys, if you're in my class and you're doing this at home, write that summary in your Cornell notes and make sure your table of contents is updated. For those of you following along at home, and for those of you who are following along in my classroom, till next time, keep doing the math.